you ever noticed how light your motorcycle helmet feels, yet it can save your life in an impact that would destroy just about anything else? That's because this thing on your head isn't just a shell, it's a carefully engineered miracle of craftsmanship and science. Did you know that some high-end helmets take up to 18 hours of hands-on work just to make one? No joke! Every gram, every fiber, every brush of paint is done by human hands. Now, let's step inside one of the world's leading helmet manufacturers. The kind trusted by MotoGP riders and everyday commuters alike. And if you love these kinds of behind-the-scenes stories about how everyday objects are secretly incredible feats of engineering, make sure to subscribe. We dive into weird factory secrets like this every week. Part 1. The birth of the shell. Every motorcycle helmet begins with a single purpose: to protect the human brain. It's the one part of the body that can't be repaired once it's damaged. That's why the people who make helmets take their work personally. In this factory, everything starts with fibers, not ordinary ones, but super fibers that are up to 30% stronger than standard materials. These threads are so fine and light that manufacturers can reduce weight without losing strength. They cost several times more to produce, but when it comes to protecting a human head, safety always beats savings. Inside the molding area, the process looks more like art than industry. All shell molds are designed in-house, and every one begins with the primary fiberglass layer. Workers known as shell experts hand-lay the fibers inside rotating molds, layering them with resin in precise patterns. Only a small group of specialists in the factory are trained to do this, a skill that takes years to master. Would you rather work in this kind of high-stakes, details-obsessed work environment, or work a more chill job? Each shell is built using more than 20 separate materials, each carefully positioned for optimal strength. Some layers include a net-like composite sheet that strengthens the shell without adding extra weight. Every shell is repeatedly inspected and weighed at every stage. Even a few grams off the target weight means it's rejected. Inspectors sign their initials and record the shell's weight before moving it forward, their personal seal of quality. Once the layers are complete, the shell is baked at around 100 degrees Celsius. The heat solidifies the resin and fuses the fibers into a single unified structure. After cooling, it's trimmed, not with a water jet, but with a precision laser, the only robotic process in the entire factory. Water jets can cause micro vibrations that might weaken the structure, while lasers cut cleanly and silently. Most people think this kind of cutting is fully automated, but it's actually done under human supervision to ensure perfection. Did that surprise you? Every shell is then measured with micrometers to check thickness down to fractions of a millimeter. Too thin, and it could flex more than intended during a crash. That's not acceptable here. The goal isn't just to meet safety standards though, it's to exceed them, because the shell uses as little resin as possible to stay light. Its surface isn't perfectly smooth, so each shell is hand-buffed with a special compound until it gleams. Here's where one of the most fascinating engineering principles comes in. Motorcycle helmets are designed to glance off impact surfaces, not absorb them like a sponge. A smooth, rounded surface helps the helmet slide across asphalt instead of catching on it, reducing rotational forces that can twist the head or neck. It's a design philosophy that turns the helmet into a controlled deflection system rather than a blunt wall. Part 2. Painting and finishing. Then comes painting, and this part feels more like a custom shop than a factory floor. The paint process involves more than 10 separate steps. It starts with a hand-painted primer coat, followed by baking, and then sanding with 3 different compounds. A second primer coat is applied and the surface is wet sanded again by hand until there's just 25 grams of primer remaining. The finish must be flawless before any color touches it. Each layer of paint takes days to complete, 3 days per color to be exact, and every coat is inspected before moving on to the next. Prior to applying graphics, workers hand-mark the helmet with templates to ensure perfect alignment. Here's the wild part. Each helmet size has its own template. The same design must be adjusted and placed differently for every size, which means precision is everything. Drop your guess in the comments. How many people in this factory do you think are qualified to apply these water decals? It's less than you'd think. Only a handful of people are trusted with this job. After the decals are applied, the shell is lightly scuffed by hand to prepare for the final clear coat. This coat is applied manually, then baked once again to harden into a durable glass-like finish. Then comes drilling for the visor holes, chin strap mounts, and ventilation ports. Because these shells are so strong, drill bits have to be replaced after just 80 helmets. Even the rubber trim that lines the edges of the helmet is applied by hand. The adhesive compound used is weather resistant, so it remains firmly on even with wear and tear. Part 3. The inner structure. Now we reach what might be the most difficult part of all, installing the EPS liner, the foam layer that absorbs impact energy. It's such a challenging task that only about 5 people in the entire factory are certified to do it. Each liner must be perfectly aligned with the vent holes and pressed into place without damaging the shell or foam. It's a delicate balance between force and finesse. The liner itself is made from expanded polystyrene foam, or EPS, and is often built with multiple densities to protect different parts of the head. Some high-end helmets mold it from a single continuous piece with variable density, eliminating weak points where separate layers would normally be glued. Every helmet also has a lifespan. Over time, heat and sweat cause the foam to harden, reducing its ability to absorb impact. So when you see an expiration date on your helmet, that's not for style, it's for safety. Chin straps are handmade and installed separately, then checked again to make sure they'll hold firm under tension. Vent scoops are glued with high-tension adhesives designed to break away during a crash. That's part of the same glancing off philosophy. If the helmet catches on the ground, the vents detach, letting the helmet slide instead of grabbing onto the surface. It's all about reducing rotational forces, because a twisting motion can be even more dangerous than a direct hit. Would you have guessed that even the vents are designed to break off on purpose? The visor system, padding, and ventilation ducts come next. Everything has to fit perfectly. The visor isn't just a piece of plastic, it's designed to detach safely in a crash to reduce twisting forces. The padding inside is customizable to ensure even pressure across your head. Part 4. Testing and final inspection. Now it's time for the safety tests. Every helmet that leaves the production line must prove that it can survive the unimaginable. In testing labs, helmets are subjected to an ordeal that mimics the chaos of real crashes, only far more controlled and precise. The most fundamental is the impact attenuation test. Helmets are dropped from specific heights onto different kinds of anvils, such as flat, wedge-shaped, hemispherical, or curbstone-shaped, each designed to replicate a different kind of impact surface. A flat anvil simulates hitting a road or wall, while the wedge or curbstone anvil represents a sharp edge like a curb. Inside the helmet, head forms equipped with accelerometers record how much G-force is transmitted through the shell and liner to where a human skull would be. The goal is simple but demanding, to keep that force well below the threshold that would cause a concussion or brain injury. Next comes penetration testing, a brutal measure of outer shell integrity. A sharp steel striker is dropped from above onto the helmet's crown, ensuring that nothing can pierce through to the head form inside. It's a direct simulation of debris or sharp edges on the road, and only the toughest shells survive it unscathed. Then there's retention system testing, which focuses on the chin strap, the simplest part of the helmet, but also the one that literally keeps it on your head during a crash. The strap is locked into a fixture and subjected to heavy dynamic loads, pulling forces that try to rip it apart. The clasp, stitching, and anchor points must hold tight without breaking or stretching excessively. A failure here means instant rejection. Roll-off tests are next. A weighted pulley yanks the helmet backward from the front to simulate the kind of motion that might fling it off in a crash. The test ensures that the helmet's fit and strap system work together to keep it securely in place, even under extreme forces. Modern testing goes beyond simple impact. Many premium manufacturers like Ari and Shoei also run rotational acceleration tests, which mimic what happens when a rider's head strikes the pavement at an angle. Instead of a straight impact, the helmet is spun violently to see how well it mitigates twisting forces that can shear the brain inside the skull. Systems like MIPS, Multi-Directional Impact Protection System, or fluid-based slip layers are often used to reduce that rotation by allowing the helmet shell and liner to move slightly relative to each other. Some labs take testing even further. Helmets are exposed to temperature conditioning, where they're frozen to -20 degrees Celsius, then baked at over 50 degrees Celsius, and even soaked in water to simulate rain. These extreme environments test how materials respond under stress, because a helmet that performs well only in a lab's perfect conditions isn't good enough for the real world. A few models are also subjected to UV exposure and solvent resistance tests, ensuring that years of sunlight, sweat, or fuel vapors won't degrade their protective layers. Even the paint finish must resist cracking under stress. Each test is brutal, repetitive, and deliberately unforgiving, and each helmet must pass them all, not just once but consistently across production batches. Manufacturers like ARRI go well beyond regulatory standards, striking more points on the shell than the test protocols require, scanning every possible weak spot until none remain. After surviving the gauntlet, the helmets undergo one final inspection. Every contour, vent, and visor mount is checked by hand. Some helmets are even signed by the craftsman who approved them, a personal mark of accountability, a signature that quietly says, "I built this with my own hands." Finally, the helmets reach packaging where only two trusted workers handle the boxing. They move with astonishing speed and precision, wrapping each one as if sealing a promise. By the time it's ready to ship, each helmet has passed through dozens of hands, hundreds of inspections, and countless of hours of human attention. Every step ensuring that the next time a rider's world flips upside down, the helmet will do exactly what it was built to do: save a life. Part 5. The Human Element. So next time you slide one on, remember, it's not just gear, it's the result of thousands of tiny human decisions made in the name of your safety. Most people think helmets are machine-made products, but after seeing all this, do you still think that's true? Which part of the process surprised you the most? Let us know in the comments, and tell us what product you've always wondered how it's made. If we pick yours for our next video, we'll feature your name on screen. We showed you how a motorcycle helmet is made, but what about the gear that goes with it? Should we show you how racing suits or riding gloves are made next? Drop your votes below. We're reading every comment.